I'll start with sort of the whole idea of where to land on Mars with this tremendous asset. When it came down to it, we narrowed our landing sites down to 4, and all of them looked really good. And as you might imagine, every single scientist had their favorite. And so we had 4 major contenders, and I kept on thinking, now that we picked Gale Crater to go to, that the odds are 75% that we picked the wrong place to go. Well, you can imagine relief landing there, and then almost right off the bat, we do find evidence of water. We see an ancient riverbed. We're now finding an environment in the near subsurface, not too far beneath the oxidized layer, of finding sort of a neutral rock. All the things that we were really hoping for to find a place that could have been habitable in its past. So as far as I'm concerned, this is fantastic. All the rest is gravy in terms of how the rover is going to go about looking around this area, because it definitely was all the indications of being a habitable environment at one point in time.
I think I'll add to that by adding an additional point, that what this does now is that I think with all the planning that Michael was talking about, going into picking the landing site and then effectively exploiting the landing site, we had 400 team members, and before we landed for about 2 months, folks got stuck into mapping this, and that helped us expeditiously find a place that when we landed, no matter where we landed, we would be able to move there and do the instrument checkouts and hopefully a good place. I think what we can do now with the issue of habitability in the bag, with a really good habitability now, we can undertake a more systematic search for a brighter carbon signal, the kind of thing that Paul was talking about. The search for organic carbon is an issue of this mission. And you want to do this as deliberately as possible. You don't want to just wander around and try stuff out. And so we have a search engine now, and there's 3 components to this, as I've stressed in the past. The one is that the primary environment has to have a mechanism by which you enrich whatever carbon signal is there, whatever reason it's there. You'd like to have a good, strong signal. But the problem is that what you see going on in these images is that there's a process that geologists call diagenesis, and it's all this chemical transformation that happens. Sometimes when you make these minerals and chemicals, they actually use the organics as part of this electron flow I was talking about. So they can be degraded. And then you leave the rock sitting around for a couple of billion years, and it's getting bombarded with radiation. This is not a simple problem, and it's going to take us a while, but I think the mission is up to it, and we're really excited to get started on that now. Maybe Dave and Paul want to say something.
Well, I don't know. I think we really ran the table with this analysis, because just coming to this place and analyzing this bedrock, finding an aqueous environment, finding what appeared to be a habitable environment, and with good preservation potential, it kind of covered all the points of what I would call just an elegant sample to analyze with our capability. So I'm really happy we landed at this spot.